Now the big question is this: why do we have two images in one? And in this case, you're wondering, why is there a black image right at the center? And we're going to dive into details about this image that was released by James Webb Telescope. And this specific image is indeed called what? A globular cluster. And this cluster is known as M92, using its near-infrared camera instrument, and it's actually composed exposure using 4 different filters. One is known as a blue filter, and the next one here is known as the cyan filter, followed by a yellow filter, and finally here we have the red filter. Now the black strip that is at the center is a chip gap, and the result of the separation between the near-infrared cameras, 2 long wave detectors, in this case wavelength, and the gap covers the dense center of the cluster. Now this is known to be too bright to capture at the same time as the less dense outskirts of the cluster. Now, one important information about this image here is that it is around 39 light years that is across, and looking into details about various descriptions and understanding of more about this cluster, there are a lot of things that you need to take away from it, which includes the following. In summary, we have first, the location of this cluster is where? Around 27,000 light years away from the Milky Way halo. And this here shows that we have the following. One of the sites of observations that was really early when James Webb Telescope was released, and this site is going to be explored by the Early Release Science, or ERS program. And now we're going to look at one of the 13 ERS programs that helps astronomers to understand how to use James Webb Telescope to make the most of its significant scientific capabilities. Now, in this article, 4 people were interviewed to give more information about this particular James Webb Telescope's experience or observations of the globular cluster, and there's some fascinating results that you should take away from this, alongside other preferences by known as Christine McQueen, who actually had our own analysis work on the dwarf galaxy WLM, and this is also part of the program. Now, one question that was presented was, what is the purpose of the ERS program? And there were 2 responses from the different scientists that talked about the responses, and one said is to study more about the population of stellar bodies and how they are really close to our solar system, in this case our own galaxy. And now looking at those number of stars, that it's really impressive how Webb is able to capture those individual stars in that cluster. We can look at the population and most importantly the physics behind how those star interactions work in those globular. Alongside, the second point that was made is understanding better James Webb Telescope capacity and how you can calibrate it to best match and understand various features of different globular systems that are either neighbors to us or something that is far away from us based on galaxy's point of view. Now, speaking of the reason why they focus mainly on the M92 Globular cluster, there were 3 points that were made, and one of them out of the 3 is fascinating, based on stellar and star evolution and how we need to understand the behavior of stars and how they evolve over time. And it's really fascinating to have that thought when it comes to this particular location that is pretty close to our solar system, and how we can be able to study those star relationships and how they evolve over time. So really fascinating to think about that first point. Now, the second point is truly impressive because of how old this cluster is. It's roughly around 12 to 13 billion years old, and this is one of the oldest cluster in or within our Milky Way. So it's truly fascinating to see the aging of stars in that location, and this can help us to understand how stars evolve based on the age and transformation of various stars, and indeed this particular cluster in various systems within our Milky Way and also outside of the Milky Way, therefore tapping into the ancient understanding of universe, or we can say the early universe, based on how stars were as they grew to become the stars that they are right now. Now, in addition, the third point is really fascinating, how much stars and here that provides a richness in the density of this particular cluster, and by that richness we can be able to get impressive measurements of stars as they are really packed together in this region. So this is really fascinating to see that picture that is utilized using the visual form of the dense packed stars with heavy mass, of course, when they are closely packed together. Now, just for perspective, it says that the center of the cluster is thousands of times denser than the region around the sun. Now, one interesting question was concerning the characteristics of this particular globular cluster and how that can help us to understand star evolution. One point that was made is concerning mass, and the other point that was made focuses mainly on distance. And what they figured based on the mass is that in terms of the bulk part of the stars in this particular region, that it actually has roughly the same time in terms of how they were formed, and also they have roughly the same mixture of elements. However, there is a wide range of masses, so it is actually a great survey spot that is important based on population of stars. That is the first point based on mass, and while the other point in terms of distance is that despite the fact that you have some of them brighter than the other, they actually have the same distance relative to us. So that is really something to think about when it comes to characteristics of a globular cluster like this, and how this can help us to understand how stars evolve. Now, in terms of comparing results between the James Webb telescope and that of Hubble telescope results, we can see that first is that James Webb telescope is actually designed to capture longer wavelength than that of Hubble telescope. So that means that it is most likely sensitive to low mass objects, which means that we can actually capture small masses that are really close to known as the brown dwarfs region, and therefore you can capture stars and suns that are pretty much 0.1 times the mass of the sun. And so it's really fascinating to be able to show that sensitivity of the Webb telescope. The next point is in terms of the time to get the information. While for Hubble Space Telescope, it will take us usually around hundreds of hours to get a low mass star. Webb, on the other hand, actually takes a few hours. So that is very incredible to show how fast Webb is compared to Hubble Space Telescope. Therefore, in conclusion, Webb is able to capture really small objects as opposed to Hubble Space Telescope. Now, interesting things about what a low mass star entails is that one is that they are known to be the most amount when you look at them in a cluster. And the second point here is concerning the light that is emitted from these low mass stars. And by emitting this light, we can actually understand the characteristics of this light and the globular cluster based on the age. And this will help us to actually know when this particular location, which is the M92, was formed in our Milky Way halo region. Now, the big question is, why is there a black spot right at the center? The reason why is because the image which uses the James Webb telescope near infrared cameras. This actually shows two models with a chipped gap. And this here shows that this chip gap that is between these two models shows that the center has extremely numerous clouds of stars, and this here produces a really bright light that you don't really need that information at all more about it. So in that case, all they had to do was that due to the extreme brightness, they had to cut it, I believe, because it's not a useful data for this understanding of this cluster. Now, looking closely at the image, when you look at the left quarter closer to the right, we see a lot of stars, and these stars here, when you look at it packedly, you can recognize it that it is about 300,000 stars that are packed into a ball that is about 100 light years across. So this is really huge when it comes to this M92 Globular Cluster, just that tiny section. And just imagine when you get closer to the center, how many more stars will be so packed that will produce that much bright light that quite impossible to count how many stars exist at that region. So that's something to think about. Now, I hope you found this video interesting in terms of understanding more about globular clusters. One interesting thing about these, which is within our Milky Way halo region, and most importantly, interesting facts about low mass stars, and finally how impressive the James Webb Telescope is in terms of understanding its use when it comes to the evolution of stars within not only our galaxy, in this case the special spot M92, but maybe in future experiments to come. So I'm really excited to see what the future observations are from the ERS region program, because of course we have 1 out of 13. How about the others? Let's see what they got for us. Now let's know your thoughts about all this in the comment section down below. By that way we can talk to you all soon. Stay smart as always and believe in yourselves.